In the middle of the 20th century, when land was limited, fertilizer was expensive, and supply chains were, pretty unreliable, people learned how to grow serious amounts of food in places most modern gardeners would just ignore. Back alleys, factory yards, refugee camps, prison farms, and war-damaged neighborhoods all became growing spaces. Old tires, broken barrels, and scrap wood were turned into food systems. One of the most productive of these forgotten methods was a tire-stacked peanut system that could produce up to 10 kilograms of peanuts in a single vertical column, without traditional garden soil and without commercial fertilizer. If you had walked through parts of rural Asia, Africa, or post-war Europe in the 1940s and 50s, you would have seen these stacked tires tucked behind houses and barns. They looked like junk piles. In reality, they were compact food factories. Today, most people have never heard of this system, and in some regions it is actively discouraged. Not because it does not work, but because it does not fit modern agricultural economics. In this video, I'm going to show you exactly how it worked, why it worked, and how you can still use it today if you understand the principles behind it. Peanuts are not like beans, corn, or tomatoes. After the peanut flower is pollinated, it sends a small stem called a peg down into the ground. At the tip of that peg, the peanut forms underground. The deeper and looser the growing medium, the more space the plant has to produce pods. Traditional field farming limits peanuts to the depth of the soil. Usually that is 6 to 12 inches. In stacked tire systems, growers created vertical soil columns 2 to 3 feet deep. This gave the plant far more room to develop pegs and pods. At the same time, peanuts are nitrogen-fixing plants. They work with natural bacteria in their roots to pull nitrogen from the air and store it in the soil. That means they largely fertilize themselves. When grown correctly, they do not need synthetic fertilizer at all. This combination of underground fruiting and natural fertilization is what makes the tire method so powerful. The original method was simple and based on available materials. Farmers and home growers collected 3 to 5 used vehicle tires of the same size. They stacked them directly on compacted ground, concrete or wooden pallets to improve drainage. The bottom tire was filled with a loose mix of composted plant matter, leaf mould, sand and local dirt. In many cases there was no soil in the modern sense. It was decomposed organic waste mixed with ash and crushed leaves. A single peanut seedling was planted in the centre. As the plant grew and reached the rim of the first tire, the next tire was placed on top and filled with the same loose mixture. This process was repeated throughout the growing season. Each new layer encouraged more pegs to grow downward, creating multiple underground fruiting zones. By harvest time, one plant could produce several layers of peanuts. The key was biological activity. The growing medium was alive with bacteria, fungi, and decomposers. Kitchen scraps, crop waste, wood ash, and dried weeds were constantly added in small amounts. This created slow-release nutrition. Instead of feeding the plant directly, growers fed the soil organisms. Those organisms fed the plant. Peanuts, through their nitrogen-fixing roots, added even more fertility to the system. Over time, the column became richer, not poorer. In practical terms, this meant one tire tower could be used for years with minimal outside inputs. High yields came from three practices: depth, moisture control, and pruning. Depth allowed more pod development. Moisture was controlled by watering slowly from the top and allowing excess water to drain out the bottom. The loose medium prevented rot. Pruning involved removing excessive top growth late in the season. This forced the plant to send energy into pod production instead of leaves. A typical setup with 4 tires, proper compost and good watering could produce 6 to 10 kilograms of dried peanuts in one season. For families with little land, this was, a survival system. There are, 3 main reasons this system is rarely promoted today. First, it does not generate profit for fertilizer companies, soil suppliers, or large seed distributors. It relies on waste materials and saved seed. Second, tire reuse is controversial because of concerns about chemical leaching. While many studies show minimal risk when tires are used above ground and not in direct contact with food, regulations often discourage reuse. Third, it promotes decentralized food production. When individuals grow high-calorie crops at home, they rely less on commercial supply chains. None of this fits modern industrial farming models. If you want to use this system now, you can modify it responsibly. Use food-safe liners inside the tires, such as thick pond liner or heavy-duty plastic with drainage holes. This prevents any potential contamination. Build your growing medium from composted leaves, kitchen scraps, coconut coir, sand, and garden soil. Avoid raw manure. Plant 1 healthy peanut seedling per column. Space your towers at least 3 feet apart for airflow. Water deeply once or twice a week, depending on climate. Stop heavy watering 2 weeks before harvest. At harvest, tip the column over and dismantle it layer by layer. Dry the peanuts in shade for 2 weeks before storage. This produces clean, long-lasting food with minimal cost. This tire method represents a mindset that has largely disappeared. It is about working with biology instead of buying inputs. It is about using waste as wealth. It is about producing calories in tight spaces when conditions are uncertain. During wars, depressions, and shortages, people did not wait for permission to grow food. They built systems that worked. This is one of those systems. If you are serious about resilience, food independence, and practical history, this knowledge is worth preserving. These forgotten growing systems were not accidents. They were developed through necessity, experimentation, and hard experience. They kept families alive when there were no guarantees. If you found this valuable, take a moment to like, subscribe, and share this channel with others who care about history, self-reliance, and real-world skills. Every subscription helps keep this knowledge alive for the next generation. Stay prepared, stay curious, and I will see you in the next episode.